Hi, in this video we will learn probability and event. Now, what is probability? It's a measure how likely the outcomes of a particular experiment or activity will result. For example, you toss a fair coin only once. Now, what are the possible outcomes? It may be a head or a tail. This collection of all possible outcomes of the trial is your sample space. We give the name of the sample space as S1, and this S1 is a set of all possible outcomes. That is, in this trial, the H and T are the two elements of the set S1. Now, we are interested in at least one head that will come up after this trial. Since there is one head that is likely to come up because we are tossing the fair coin once, then we have the event like this. That event is at least one head. We give the name A to the event, and it is having one element inside, that is H. This A is also a set, and we can see that this A is a subset of the sample space S1 because it is taking element from this sample space set. We are interested now how likely at least one head will occur when we go for the trial. So the probability that A will occur will be the size of A by S1. Here the size of A is 1 because there is only one element inside the set A. And here this S1, that is H and T, that is 2. So 1 by 2 becomes 50%. That means we can say that the probability of getting at least one head from this trial is 50%. We define another event, that is B, and this time we want at least one tail. So the set B is having only one element, T, that means tail, and we would like to go for the probability of this event B. So the probability of B will occur will be equal to size of B by S1. Here also the size of B is 1, that is one single element T inside. So this is also 50%. Thus, what we learn, the probability of some event is outcome count based on the criteria of the event by outcome count without any criteria. So the numerator is an outcome count based on the definition of the event, and the denominator is also the outcome but without any criteria, that means the whole sample set. Thus, the probability is nothing but a relative frequency of some event. Let's go for example 2. This time we toss the fair coin twice. These are the possible outcomes we may have. Since we toss the coin twice, that means there will be two trials. In both the trials, we may have head, or in the first trial, we may have head, and the second trial may have tail. The first trial, tail, the second trial, head, and in both the trials, we may have tails. So, this is our sample space. We give the name sample space S2. So, the S2 is a set of all possible outcomes here. Here, the sample space size is 4. This time also, we are interested in the same event, that is at least one head, just like before. So, event at least one head, we give the name of the event as C. And now, this set C is having 3 elements because in HH, there is at least one head, so we can count that. We can count this one also because there is one head. Here also there is one head. But this last one is not having a single head. So we omit the last one and we include these 3. Now for probability of this event C will occur will be going like this. Size of C by the total sample set, that is S2. The size of C is 3 here and the size of the sample space is 4. So it goes 3 by 4, that is 75%. Thus the probability that C will occur is 75%. We similarly declare the event D as at least one tail. So this time this HH will be excluded and these 3 will be included. So the same way goes, size of D by S2. This time also size of D is 3. Your sample space size is 4. So it is also 75%. Now you notice one thing, that each time we assume the coin is fair, that is not loaded in any way. This we call classical approach, and it is very theoretical. Now, can you have in practical a really fair coin which is fully balanced? I believe not. In that case, we go for frequency approach. In this approach, we go for n trials where the number of trials is very large, and if we see that an event E occurs in h trials out of those n trials, then we say that the probability of E is h by n. That means we perform n trials and we count the outcomes of the event. That means without assuming the degree of fairness of the coin, we are going for the trials with the experiment and we are trying to find out the frequency of the event. That is why this is called empirical probability. For example, say we have an event E and we want a head. So this event E is having one single element H inside. Then what is the probability of that event? We have two possible outcomes, H and T. So our sample space size is 2. We go for 1000 trials and our head count is 479. Why not 500? It should be because the coin is fair, but during tossing, there are other parameters that influence the trial. So we get the head count 479 instead of 500. So we estimate that the probability of that event that we will get head is 479 by 1000, that is almost 48%. This probability of an outcome is called long-term relative frequency of that outcome. Let's go for an interesting observation. Here we have the point that is 0.5 and this is our theoretical frequency. On the left hand side we have got 0 to 0.4 and on the right hand side we have got 0.6 to 1. So this is our whole range of probabilities from 0 to 1. Now we tossed a coin 100 times. We got head count 79 instead of 50. So our probability is 0.79. That stands here. So there is a deviation between the theoretical frequency 0.5 and the observed frequency, that is 0.79, and the amount of deviation is 0.29. We tossed the coin 1000 times now and I got the head count as 385. So the probability of this event will be 0.385, that is almost 0.39. So here we go with 0.39. Now you notice that the deviation has reduced to 0.11 from 0.29. We go for 10,000 times. We got the head count 5,623. So the probability is almost 0.56. So here is 0.56 and there is a deviation of 0.06. So what do you see? You increase the trial numbers and your observed probability comes closer and closer to theoretical probability. This is called law of large numbers. That states that as the number of trials increases, the relative frequency obtained tends towards the theoretical probability. Now there is a drawback of the classical approach as well as the frequency approach. The words equally likely are vague. That means you cannot guarantee that the outcomes head and tail of a fair coin are equally likely. A small bias in the coin will make the coin biased to either towards the head or towards the tail. In case of frequency approach, the large number is actually a vague. In the previous slide, we have seen that we have performed 10,000 times to get the observed frequency closer to the theoretical frequency. Now, if you increase more and more trials like this, then we will come closer and closer to 0.5. But what is that number? So that is the question. So this large number concept is also vague. To deal with this situation, the following axioms are followed. Axiom 1, for every event A, the probability will be greater than equal to 0. Axiom 2, if you are sure or certain about some event A, then the probability of the event A will be 1. And the third one, for any number of mutually exclusive events A1, A2 like that, the probability of A1 union A2 union all other events will be probability of A1 plus probability of A2 plus ... Let us see through an example for this axiom 3. After rolling a die, I want 5 or 6. That means any one of these 5 and 6 will make me happy. Now these events regarding the 5 and 6 are mutually exclusive events. That means if 5 comes, then 6 cannot come, or if 6 comes, then 5 cannot come, right? So A1 is my event that is 5 and A2 is another event that is 6, and these two are mutually exclusive events. So probability of 5 union 6 will be equal to probability of 5 plus probability of 6. Now probability of 5 will be 1 by 6 because the sample space is 6 because there are 6 faces in the die and we have one element inside the A1. So it is 1 by 6 plus probability of 6 is also 1 by 6. That is 2 by 6. That is almost 33%. So I hope you have the clear concept about the probability and the two approaches, that is classical approach and the frequency approach, and the drawbacks. You also have learned about the axioms, and also you have a clear idea about event. If you have any question, then you can write me in the comment box. Well then, we meet in the next video.